Look up tonight, and almost nothing you see is really there. Not in the way you think. That star just above the horizon, the light hitting your eye left its surface before you were born. Some of it left before your parents were born. A few points of light up there are already gone, extinguished, and the universe simply hasn't gotten around to telling you yet. You are not looking at the sky, you are looking at the past. And that's before things get strange. Here's the question that's going to follow us through everything that comes next. If we could travel as far as physics allows, past the stars, past the galaxies, to the actual edge of what can be seen or known, what would be there? Not in science fiction, in reality. What is actually physically at the end of the observable universe? Most people assume there's an answer waiting for us. The way there's an edge to an ocean. There isn't. And the reason why is stranger than almost anything else in astronomy. Start close to home, because even that isn't simple. Our sun is 8 light minutes away. If it vanished right now, you'd keep feeling its warmth and seeing its light for another 8 minutes, living inside a lie made of physics. Now stretch that out. The nearest star system beyond our own, Proxima Centauri, is so far that light, the fastest thing that exists, takes over 4 years just to cross the gap. A rocket at our current best speeds would take tens of thousands of years to arrive. That's the nearest star. Now here's where things start to feel less like distance and more like time travel. When astronomers point a telescope at a galaxy a billion light years away, they aren't seeing that galaxy as it is. They're seeing it as it was a billion years ago, before some of the chemistry that makes up your body had even finished forming. Some of what we photograph tonight may not exist anymore in any recognizable form. We are, quite literally, a species that studies ghosts. But this creates another problem, a bigger one. If looking further away means looking further back in time, then there's a limit. Not a wall in space, a wall in time. Because before a certain point, roughly 380,000 years after the Big Bang, light itself couldn't travel freely. The universe was an opaque, glowing fog of plasma, too hot, too dense for photons to escape more than a short distance before slamming into a particle. It would be like trying to see through the inside of the sun. Then the universe cooled just enough. Space became transparent, and that first light, the oldest light that has ever existed, is still out there, stretched across billions of years into microwaves, arriving at Earth right now in every direction, all the time. We've measured it, we've mapped it. It has a name astronomers say almost casually, the cosmic microwave background. But say it slowly, and it stops sounding casual at all. It is the afterglow of creation itself still arriving. That's as far back as light can show us. Not because our telescopes aren't good enough, because before that moment, there was nothing for light to travel through. Except nature wasn't finished being strange. Here's the part that quietly rearranges how you think about the edge of the universe. Because of how space itself has been expanding since that first flash of light, the most distant galaxies we can detect aren't actually where they appear to be anymore. Their light left them roughly 13.4 billion years ago. But during that entire journey, the space between us and them kept stretching, like a photograph pulled wider and wider on all sides. By now, some of those galaxies are estimated to be over 46 billion light years away, even though the universe itself is only about 13.8 billion years old. Read that again. The universe is 13.8 billion years old, but the observable universe is over 90 billion light years across. That isn't a contradiction, it's a clue. It means space itself is not a fixed stage that things move around in. It is the thing that's moving. Galaxies aren't racing through space away from us. Space is expanding between them, carrying galaxies along like dots on the surface of an inflating balloon. None of them moving, all of them getting farther apart anyway. If you're still here, and your sense of scale hasn't completely collapsed yet, you'll probably enjoy what comes next, because this is where the story stops being about distance and starts being about a wall we genuinely cannot see past, because there's a horizon, an actual cosmic horizon. Beyond roughly 46 billion light years in every direction, galaxies exist, almost certainly, that we will never see. Not because our instruments are too weak, because the space between us and them is expanding faster than their light can cross it. Their light is running toward us and losing. It will never arrive. Not in a million years. Not in a trillion. Those galaxies are permanently physically cut off from us, even though nothing is technically stopping the light itself from trying. We call this the observable universe. But that name is almost a trick because it implies we're looking at the universe, when really we're looking at the small sphere of it that happens to still be reachable by light. Most cosmologists think the actual universe extends far beyond this, possibly infinitely. We simply have no way to know because the information can't get to us. We're sitting inside a bubble of visibility, and the walls of that bubble are made of nothing but time and expanding space. So what happens if you actually traveled there, to the very edge of what we can detect? You wouldn't hit a wall. You wouldn't see a boundary, a sign, an edge of the universe like the edge of a map. You'd simply find yourself in the middle of another observable universe, your own bubble of 46 billion light years, centered on you, with its own horizon, its own galaxies newly visible that weren't visible from Earth, and its own galaxies now forever out of reach behind you. Every observer, everywhere, at every moment, sits at the center of their own horizon. There is no privileged edge. There is no center. There is only ever your bubble, and the ones you'll never get to see inside of. This is the part that changed how I think about space. Honestly, we talk about the edge of the universe like it's a destination. It isn't. It's a property of you, of wherever you happen to be standing, and how much time light has had to reach you. Move a billion light years in any direction, and the edge moves with you, exactly as far away as it was before. Which brings us back to that same point of light above the horizon, the one from the very beginning, whose journey started before you existed. It isn't just old light anymore, is it? It's a message from inside a boundary that only exists because you're the one receiving it. Somewhere out past what any human will ever see, there are galaxies forming, colliding, dying, entirely unaware that their light is running a race against expanding space that it can never win. Light that will travel forever and arrive nowhere. We spend so much of our lives worrying about distances that are cosmically meaningless. The length of a commute, the miles between cities. And yet here we are, a species on a small rock, who figured out that the sky itself has a horizon built from nothing but time, and who did the math to prove it. So the next time you look up, you're not just looking at stars. You're looking at the edge of what's knowable, a boundary that exists only because you exist, standing exactly where you are at exactly this moment. Which raises the question none of us can quite answer. If every observer carries their own edge of the universe with them wherever they go, then what exactly are we actually at the center of? Which object completely changed the way you think about space?